We will discuss graphs of quadratic functions. In this lesson, we will learn to write the equation of a quadratic function given vertex and a point on the graph, and then write the equation of a quadratic function given intercept on a graph, and then lastly, write the equation of quadratic function in standard form given the equation in general form. What you see here is the outline of the steps that you have to follow to write the equation of a quadratic function given vertex and a point. So the first step is to identify the horizontal shift. The horizontal shift is just the x-coordinate of the given vertex. That is your h. That is the value h. And then identify the vertical shift. The vertical shift is the y-coordinate of your vertex, and that is the value k. And then you substitute these values to the given function here, f of x equal to a times quantity x minus h squared plus k. And then after you substitute h and k here, you go pick the point, the given point, and get the x-coordinate and the y-coordinate. The x-coordinate will be replaced here in the x, and then the y-coordinate for the given point other than the vertex will be replaced here. With that, you can solve for the value of a, the coefficient for your leading term. And then once you solve the value for a, you can just simplify or expand and simplify and write it in general form. So to exemplify the process, we are going to consider the example here. Given a vertex which has the x-coordinate equal to 1 and the y-coordinate equal to -2, and a point with the given coordinates here 4, 5 on a parabola, we want to write the equation for such parabola. So as a first step, we will identify the horizontal and vertical shift, and that is just like the vertex of the parabola. The horizontal shift, as discussed, is the x-coordinate, so that is your 1 in this case, and the vertical shift is the y-coordinate, and that is equal to -2. Then once you have that, you're just going to plug it in to the given function here, or to this form here, f of x equal to a times x minus h squared plus k. So you plug in your h and k value, and the point 4, 5 on the parabola to the function f of x equal to a times x minus h squared plus k. So with x equal to 4, we are going to replace x here by 4, and the f of x here will be replaced by this number here, which is equal to 5. And then we have this given equation that we are going to solve by simplifying first the one inside the parentheses. So we have 4 minus 1 is 3, and then squaring that, we have 9. So we have 9a minus 2 is equal to 5. Then you transpose this -2 here on the other side of the equation, and that leaves you with 7 equal to 9a. And then solving for a, you get a equal to 7 over 9. Then after that, you are going to plug in all the given information and all the information that you solved to the function here, f of x equal to a times x minus h squared plus k. So with a equal to 7 over 9 and h equal to 1 and k equal to -2, we have this expression here. Then we will go ahead and expand expand x minus 1 squared. That would be equal to x squared minus 2x plus 1 using the FOIL method or the formula. And then distribute this 7 over 9 to each term inside the parentheses. We have 7 over 9 x squared minus 14 over 9x plus 7 over 9. And then you just copy -2 here. That's how you get -2. And then simplifying this will give you this equation here for your parabola. Now for this next method here, suppose we are given the intercepts on the graph of the parabola. We're given the x and the y-intercept, or we're given the graph of the parabola and we're able to identify the x and the y-intercepts. If that's the case, we can use this formula here to find the equation of our parabola or of our quadratic function. This r sub 1 and r sub 2 are the roots of the function, or the roots of the parabola, or the intersection of the parabola at the x-axis. In other words, these are the x-intercepts of your parabola. And from there, if we have another point, say for instance the y-intercept, we can use that to plug into the given function so we can solve for a. Because notice that in this formula, we only need a and the two roots to be able to derive the equation of our quadratic function. So once again, let us summarize the steps that you have to follow to find the equation of a quadratic function when given the intercepts. First, you use the x-intercepts to find your r sub 1 and r sub 2 of the quadratic in factored form. And then you use your y-intercept and your f of 0 to solve for the constant a. And then expand the quadratic function into general form. To illustrate this, we consider the following example. Given the x-intercepts of -2, 0 and 1, 0, and the y-intercept of 0, -3 on a parabola, write the equation for the quadratic function. So to solve this, we are going to use the factored form of the quadratic function given by this formula here, where r sub 1 is r sub 1 and r sub 2 are the x-intercepts of our parabola, and we can solve for a by using the y-intercept. So let's start by plugging in r sub 1. R sub 1 could be -2, and then our r sub 2 will be equal to 1. So plugging in to that equation, we have this. And then next is to solve for a. But before we solve for a, let us first simplify this. We can simplify, or since we have double negatives here, we will just write that as x plus 2. So that will turn to positive. So we have x plus 2, and then copy the other one, x minus 1. So we therefore have f of x equal to a times x plus 2 times x minus 1. Then next, we will need to find a. To find a, we will use the y-intercept, this point here, and plug it in to this given function. So we'll plug in that values or those coordinates to that function and solve for a. So to do that, we will replace our x by 0 and our f of x by -3, or f of 0 by -3. So with that, we will have f of 0. So if we replace x by 0, you have f of 0 equal to a times 0 plus 2 times 0 minus 1. And then you simplify that, you replace f of 0 by -3. And then 0 plus 2 is equal to 2. And 0 minus 1 is equal to -1. And 2 times -1 is equal to -2. So you have -2a is equal to -3, which you can solve for a now by dividing both sides by -2. A is equal to 3/2. Now that we have found all the needed values, we can then expand the factored form to get the general form of the quadratic function, with a equal to 3/2 and our x, or r sub 1, is equal to -2, and that gives us x plus 2. And then we have r sub 2, which is equal to 1, that gives us x minus 1. We then have this given expression here, and then we can multiply using FOIL method the product x plus 2 and x minus 1. So using FOIL method, that would result to x squared plus x minus 2. Then after that, we are going to distribute 3/2 inside the parentheses, or multiply that to each term inside the parentheses, and that would result to 3/2 x squared plus 3/2x minus 3. This is now the general form of the quadratic function with that given information. And so for the third objective, we want to learn how to write the equation of a quadratic function in standard form given the equation in general form. And so given an equation in general form, that is of this form here, ax squared plus bx plus c, we want to be able to convert it to a standard form in the form f of x is equal to a times x minus h squared plus k. So the first step is to identify the values for a, b, and c by looking at the coefficients of our equation in general form. So a is the coefficient of x squared, and b is the coefficient of x, and c is the constant. And then you find the h, or the x coordinate of the vertex, by using the formula that we have previously, which is h is equal to -b/2a. So using the information for a, b, and c, we can find h. And then we can find k, or the y coordinate of the vertex, by substituting h to f. So substituting h to f in this expression here, we can solve for the k value. Then once we have that, we can then go and use all the information we have, and then just plug it in to this formula here, f of x equal to a minus x minus h squared plus k. And so for example, we are to rewrite the quadratic function f of x equal to 2 minus x squared minus 4x plus 5 into standard form. And so to do that, we will first identify the values of a, b, and c. A is the coefficient of x squared. So this number here is the value for a, and the coefficient of x, including the sign, is your b, and the constant here is c. So now that we have values for A, B, and C, we can then find H by plugging into this formula here where H is equal to negative B over 2A. So using B as equal to negative 4, we have the negative of negative 4 in the numerator, and A here will be replaced by the value of A that we got, which is A is equal to 2. So we have 2 over 2 in the denominator. So simplifying this, simplifying H, which is equal to negative of negative 4 over 2, that gives us 4 over 4, and that is equal to 1. So H in this case is equal to 1. So after we've solved for H, we can then solve for K by just plugging in H to f of x. So we will replace x here by h. So in the expression, all the x's here will be replaced by h, or by the value of h. In that case, h is equal to 1. So we are going to evaluate the function at x is equal to 1. Therefore, we have 2 times 1 squared minus 4 times 1 plus 4. And when you simplify this, that would give you a value of k. So in this case, k is equal to 3. And then finally, we can rewrite the equation in standard form by plugging in our values for h, k, and a to the function. So we have f of x is equal to 2 times x minus 1 squared plus 3.